Hi, welcome to video 6.9 on vertex form of quadratic equations, and we're on page 9 of your purple packet. So just like linear equations have different forms like slope-intercept and point-slope and standard form, quadratics have standard form, which is the ax squared plus bx plus c that you're familiar with, but they also have a vertex form, and that's what we're going to take a look at today. And it has to do with transformations. So we're going to look at transformations that we're already familiar with and what that means for vertex form. So remember that x squared looks kind of like that, and we have, okay, so this is our x squared, and if we add 2 to it, that makes it go up 2 on our axes. So that would mean our vertex, instead of being 0, 0, would be 0, 2. On this one, that makes it go down 4. So that makes our vertex 0, negative 4. Right here, this means we are going to the right 3. So our vertex, instead of being 0, 0, would be 3, 0. Here, that makes it go left 1. And so that's negative 1, 0. Here, that reflects over the x-axis, and so that's still going to be a 0, 0. It's just going to be upside down of where it was before. This one, it is going to be, think of it as stretched, or you can think about it as growing faster, but it's still going to start in the same place, or the center will be in the same place, so it's still going to be 0, 0. And then this one will have 2 things happen to it. It is going to go right 5, and it is going to go down 1, and so that makes our vertex 5, negative 1. So now we're kind of looking at what that means about our vertex of our parabola. So what do we notice about the x value compared to the function? So 0, 0, if it has 3, it's showing up there. If it has 1, showing up there. So it's the opposite of that. And then this one, 5 and 5. So it's x minus the vertex value of the coordinate, the x coordinate is what shows up in there. So it's x minus whatever your x coordinate is of your vertex. And then with the y, so here's our y, so if it's 2, it's plus 2. If it's negative 4, it's minus 4. So this one, it would be y plus, it's going to be plus the vertex value of our y coordinate. Oops, I'm sorry, you can't see what I'm writing. Okay. It's going to be plus the vertex value of our y coordinate. Okay, so let's see what that actually does for us in terms of graphing. So these are just a reminder of our translations, reflections, and dilations that you've seen before, and also a review of the standard form, and then this is our vertex form. So it looks like this, where h is going to be your x coordinate of the vertex, and then k is going to be your y coordinate of the vertex. So like this right here, our a is going to be 2, our h is going to be right here, and it's 1 because it's minus h, so that's 1, and then my k is going to be negative 4. Because this is going to be plus whatever my k is, and this is going to be minus whatever my h is. So my vertex is going to be 1, negative 4. So that means that I can just go over here and do 1, negative 4. And the nice thing is, once I have my vertex, I also have my axis of symmetry. So I can do that. And my axis of symmetry is going to be x equals 1. And then my y-intercept, I can just go ahead and put 0 in here. So if I put 0, minus 1, I get negative 1 squared, which is 1, times 2, so that's 2, minus 4 is negative 2. So I get 0, negative 2. And if I went through that too quickly, it looks like this, 2, and then I put 0 in for x, and then I just calculate and got negative 2. And so my transformation is that it is stretched vertically. That's what the A tells me. It's growing faster, and that it is right 1, and it is down 4 from where the last one, where my x squared is. Okay, so 0, negative 2 is right there, and then my axis of symmetry, and then it looks like that right there. Okay, let's try another one. So this one, my vertex, this is going to be negative 4, and that's going to be negative 3. My A is 2, my H is negative 4, and my K is negative 3. My axis of symmetry is going to be x equals negative 4. It's whatever your x value of the vertex is. So negative 4, 1, 2, 3, 4, and it's going to be at negative 3. So there's my vertex. My y-intercept, if I put 0 in there, I end up getting 29. So I have 0, 29. So that's going to be pretty high up. I know I'm going to grow pretty quickly. My transformations, it's left 4 because of that. It is down 3 because of that. And it is stretched vertically. Okay, so here I could do a couple things. I could solve for my zeros if I wanted to. I could try and put it in a different format, or I could just substitute something in. So I'm going to substitute like negative 3 in to see what that would be. So if I put negative 3 in there, that's going to give me 1. And so 2 times 1 is 2, minus 3 is negative 1. So that means if I go here, that's negative 3, negative 1, and then axis of symmetry, I go there, and I know it's going to go up really fast because my y-intercept is going to be 29. So it's going to be pretty steep like that. Okay, next one. This one is, my A is negative 1. My H is going to be 3 because it's minus 3. And then this one is going to be positive 5. So my vertex is 3, 5. So 3, 1, 2, 3, 4, 5. My axis of symmetry is x equals 3. My y-intercept, if I put 0 in there, that's going to be 0 minus 3, which is negative 3, squared, which is 9, with a minus in front of it. So negative 9 plus 5 is negative 4. So my y-intercept is 0, negative 4. So 0, 1, 2, 3, 4. And then I can do the same thing on the other side. And so my curve looks like, whoops, like that. A little wobbly, but close enough. And then this one, it is, the negative means it's reflected. Reflected over my x-axis. It is moved to the right 3, and it is up 5. Okay, I'm going to have you try the next 4. So there's 1 here, and there's 3 on the next page. So go ahead and pause while you do that, and then come back and you can take a look at the answers. Okay, here are the answers. So there's the one at the bottom of the page. And here's the next ones. Oh, these have x-intercepts on them. So the x-intercepts would just be where y equals 0, or if you factored the equation, what they would be, what would be your roots or your solutions. Okay, go ahead and mark anything that you had problems with, and we can talk about them next class.